this immune system stuff that we have to get through. First off, I want to talk about the avenues of attack, how you could get an infection or a pathogen coming into the body. And I think probably the most important way to see early on is going to be an avenue of attack through maybe the digestive system, the respiratory system, the urinary tract, or a break in the skin. So these are the ways that you can have a nasty, as I'll call it, or a pathogen come into your body. I think some of these, very well aware of. Some of these I don't really care to discuss because I don't teach that class. But like for digestive system, you know you've had a bad burrito from the Bell once. That would be an avenue of attack. A break in the skin, not as much of a problem these days with a boo-boo, yes. Which is not a problem these days because of Neosporin, right?
That's my favorite.
Yes. Respiratory system, that'd be like the flu, influenza, that's a virus, or the common cold is a virus. Those are different avenues of attack. I'm not really going to get into the urogenital tract or the urinary tract because that's a different subject. We're not going to get into that. As far as your routes of attack, where these viruses or bacteria or these nasties can be, you can find them circulating two types of circulatory fluids. I would say lymphatic system to some degree, but certainly circulatory system. When the virus enters in the body and it starts doing all of its crazy things, it's probably going to be in the circulatory system. That's where it's going to be found. As George W. Bush would say, there's a couple of evildoers that we have to focus our efforts on. And so we're going to focus our efforts on this listing of 5 general evildoers. These guys right here are the ones that would start the attack process. Your viruses, bacteria, fungi, or mushrooms, molds, protists, and cancer cells. And these are all the different nasties that are out there. And collectively, we can call them a pathogen, which now for some reason that word doesn't show up too well. So that word up top is pathogen. And all a pathogen is it's one of the nasties that are out there that will use your system as a habitat and as a food source. So it uses your stuff. It uses your system. So you suffer from the disadvantages that you do because these pathogens are using your setup. Now, I've written off to the side from each of these 5, your bacteria, your viruses, your fungi, your protists, your cancer cells. I've gone over some of the major types, or like very common types, like with viruses, you know, HIV, the flu.
What is TB? Sorry.
TB is tuberculosis.
I have a question. Did you record this first one?
No, I'm recording it right now. Thank you. But all these guys that you see often, the red writing off to the right hand side, those are just like your common forms, if you will. Like for protists, malaria, probably the most commonly mentioned protist. There are other ones out there. Protists typically, though, in our country are not an issue because protists love aquatic environments, and so you would expect a protist to be free living in a water source. But all of our water that we drink is most of the time treated. So I would suspect that there wouldn't be an issue really with protist count and protist infections in this country due to the treatment of water. But like in Africa, where water treatment is maybe not as prevalent as it is here, there would be a problem with protists. And what they do is they typically, again, just like any pathogen, circulate your body. A lot of times, though, they cause things like organ damage. So there is like a very, very big negative that's associated with them. For fungi, athlete's foot, and for cancer, I would say that's technically a pathogen, maybe not one that you necessarily ingest or that you find coming into your body. It's kind of a self-created pathogen, which is kind of why it's always a big problem to address. Yes, sir?
Wasn't there some kind of protest thing going on a year ago, like some water supplies, like public parks and stuff?
There's very, very commonly like a protist problem that can be found just about anywhere. So to say that like a water source has a protist problem, every water supply does. Now, I believe Lake Texoma was recently having like a problem with like mussels or something along those lines.
You were talking about last year, like Fort Worth pools were closed because they had lakes in Pleasant.
Oh, they did?
Yeah, and then Lake Travis had a big problem with it too. They had like a bunch of cases of people going to the hospital for some.
For like Plasmodium would be a very prevalent, protist. That would be like a type of amoeba, basically. Yeah, this is they cause all kinds of issues. Absolutely. Was there any deaths at all through that?
I don't know, possibly.
I would say that it's likely probably if there's 100 infected individuals, probably there's probably at least one death. I suspect. They're typically pretty negative. These little protists, they're little nasty stuff. As far as how you develop or how you are able to create some of your cells that go off and fight these infections, I want us to talk about how you get your red blood cells and your white blood cells, and I really want to focus our efforts today on the white blood cells because those are the cells of the immune system. Those are your closest allies in your quest against the evildoers. I think it's important to realize that this starts out with a pluripotent set of stem cells. And I think we're pretty used to that term, pluripotent stem cell, especially after we went to the genetics concert with Sam Ryan. What does pluripotent mean? It means that it has the ability to differentiate. It's a stem cell. So it's a differentiatable stem cell. And that's what Sam Ryan had taught us back in the day, that a pluripotent stem cell was. And what happens is these pluripotent stem cells in your bone marrow can become one of two types. They can become a lymphoid stem cell, or a myeloid stem cell. And from there, they can differentiate into more specific types of cells. Your lymphoid stem cells become your B cells and your T cells. Those are your lymphocytes, we call them collectively. So when I drop the term lymphocytes, I'm referring to B's and T's, as opposed to your leukocytes, which I didn't throw that in there. I should throw that in there. These guys over here, I'm really going to focus on right through
Can
here.
you spell the is that myeloid? M-Y-L?
M-Y-E-L. That's an E, and that was just my quickness this morning. These right here are going to be your leukocytes. Neutrophils, basionophils. That's P-H-I-L-S. The monocytes. All these different little types of leukocytes that you would find free-floating in the cardiovascular system.
That's all on top right.
Eosinophils. I think it's just ES. If there's an O, it's not. You don't pronounce it with an O in there. But it could be like a. I don't think it would. There would be a silent O at that point, which is kind of weird. I would say ES. Basophils, P-H-I-L-S. Good stuff. Thank you. Let's move on to maybe start talking a little bit about your different lines of defense. So as you're trying to protect your body from the nasties and the evils of the world, you have to have like several different levels, I think, of defense that you would be concerned about using. And so we're going to talk about your first line, then your second and third line, and we'll kind of teach this chapter from a perspective of there are multiple levels of protection that we're going to see here. Your first line of defense is going to be a very non-specific defense. It's going to be like a barrier. And we'll examine each of these levels in just a second, but for right now I just want you to see that there's 3 levels. This first level is going to be a barrier, very broad, very external barrier. It can include skin, mucous membranes, and other fluids that are secreted on the outside of your body. Secreted.
Mucous membranes, so that'd be for kind of like outside.
Mhm.
Kinda like-
And when I say outside, I mean it can be like lining any tissue. Like that would be nose, would be a perfect example. Your second line of defense will contain your leukocytes, your white blood cells, the big killer cells that are not very specific. That's why I wrote it's a very non-specific, like patrolling type of defense. The white blood cells that are mentioned in that second line are going to be killers of all cells that are not labeled with the U protein or the U carbohydrate, but not very specific at all. And then finally, your real immune system, the actual learning immune system that can be stimulated with a vaccine or stimulated with antibodies, is your third line, which is going to be a very specific and also a very acquired system. When I say acquired, that means that you have to actually gain that knowledge. So if you want to be exempt from the flu, then one is to avoid it. But if that's not possible, it's you have to encounter it and learn how to fight it, or be vaccinated for it. That's what acquired means. You have to gain knowledge on how to fight the infection quickly, so that you don't display symptoms of that disease or of that issue. Your third line of defense contains your actual lymphocytes. It contains those B cells and T cells, the cells of the immune system. Good? Any questions about your different lines of defense? Are we okay with the way that this presents itself? And the way it should work out is it should work that your first line, which is a very, very specific, or is very non-specific, will work first, and then there's your second line, and your third line of defense is only for the things that can make it past the first 2 barriers, or make it past the first 2 lines of defense. So don't use the term barrier. Is it hot in this room, or is it just me?
How's your weekend?
It was good. Thanks for asking.
How was Cecil's on fire?
We didn't go. They canceled.
Was it you or her?
Cumulative decision. It was us.
Stay in and watch the movie.
Nope.
I hope that was recorded.
Oops. I'm going to take each of these lines of defense apart and kind of just talk about each of them. Your first line of defense, again, is I think really these 5 things that you see here. It's a barrier or a trap, an elimination method, or a unique pH. It may also include some lysozyme enzymes. Between these 5 things, you kind of provide your body with this barrier that can stop any evildoer from infiltrating the chamber that is your body, or the area that is within your body. So these are the first lines of defense. This is like the border, if you will.
We don't do it very good.
No, this system works out really well.
Our border.
What do you mean? American border?
Yes.
Yeah. That, I mean, I'm talking just about a border in general.
No, I know.
Oh, you're saying the American border's not any good? Yeah. Well, at least this one's good. And it's better that you be alive than you have a border problem.
Sure.
So, be thankful for good borders. As far as your barrier, I mean, like skin, I would say is a good one. A trap would be like mucous membranes. Like, I mean, there's plenty of like times when like you cough up and you cough up a little bit of fluid. You know what I'm talking about? That fluid has got some bacteria in it. Question.
The second word next to sweat, what is that?
Tears.
What is that? What is tears?
When you cry, when something's sad.
Explain. What is that word?
Okay, what is a tear? When something sad happens, like when Glee gets canceled, and we all cry.
No. What do you mean cry? This is a new word for me.
He has his finger.
Okay, I really thought there was a question about like how could tears be a defensive mechanism, but
Yes.
but now it's just a question of like what does to cry mean? No, like when there is crying and when there is a tear, what a tear contains is it contains like salt, and it contains a couple of other enzymes that are collectively called lysozymes that actually are able to break the peptidoglycan wall of a bacteria. It's like as you cry and the tear streaks down your face, and the same thing goes with sweat. Because of its salt concentration as well as the presence of this enzyme, it's able to crack open a bacterial cell wall and then thus kill the bacteria. So crying and sweating is actually, you know, how they say a good cry is good. Well, I got a second reason it's good.
Isn't sweat? Isn't that basically urine?
I don't want to say that because urine refers to a collection of fluids that's found
Is
like
it basically the same stuff?
The same stuff that is in urine is everywhere. It's just that the term urine means that it's a very concentrated form. There's very little water in the urine. So it is the same chemicals, granted, but it's not as near as concentrate as it is coming from the kidney. That's why the kidney is designed as it is, to concentrate that down and to yank it back out your water so that you can maintain your water.
Yeah, so tears would be like if you got something in your eye, or just in general.
It could be, or it could just be general. Like whenever you cry, even if it's sad, because again, maybe the last Harry Potter movie was very moving to you. Whatever the reason is, there's gonna be that. I mean, Harry Potter still lives because he's killing the bacteria on your face.
Spoiler alert.
Did he die? I thought he died in the movie.
He died.
He does kind
So-
of die, but then he like.
He dies and then comes back to life.
Well,
I have a question. Mr.
like seriously, guys, it was fake from like the first 5 minutes of the first
it's
movie.
real.
So, question, Adam.
It's only in Britain.
So somebody told me this. I'm not sure if it's true. I didn't really believe it, but they said that like some athletes
We're okay with this stuff about your first line of defense. So let's go and finish up today's notes by talking about the second line of defense, which is your patrolling cells. The guys that are on patrol, which can include cells as well as some proteins.
Bodyguard.
Neighborhood watch.
Neighborhood patrol, basically.
They don't do
Yeah, well, honestly, these guys don't do a lot either because they're not 100% effective. These guys are only moderately effective. They will kill foreign cells, cells that don't have the label of you on the outside, so they kill the foreign cells that enter. But again, the effectiveness is not certainly 100%. And one of their major problems is that you lack a memory to be created when these cells are used. So I always think of these guys as like very large cells, but very slow in movement, and these massive killers that are very destructive but have no stealth or rogueness about them. They're not very swift, if you will. Maybe that term would be appropriate. Yes, sir.
You just said like they kill already. Would that be why people reject weapons? Like from this.
This is one of the reasons why that they do, yes. Which is why people that are having that issue are taking immunosuppressants.
Wait,
See?
I didn't hear what you said.
First line of defense there, Adam.
Isn't it ironic the day we start talking about the immune system on sick?
Yep. First line of defense. Elimination. Right there. Mucous membranes. Biology is everywhere, my friends. Including in Adam's hand, now in my trash can. As far as your second line of defense, some of your key members, your leukocytes, the complement system, and the inflammatory response, which we kind of saw today on questions 1 and 2 of the quiz. The leukocytes, your big phagocytic white blood cells, big cells, no memory. They go around and they just kill anything that is not natural to the body. Again, they will destroy any cell that doesn't have the U label on the outside of it. And you're like, what's a U label? It's a made-up term that I made that basically refers to the carbohydrates or proteins that identify a cell as being yours from your one zygote cell all those years ago. Your complement system are protein killers. These are going to be little proteins that are fairly random in their movement, but these proteins are found just about everywhere, and very commonly they are found to, or what they do is they work to basically destroy anything that's foreign. Inflammatory response. This is the involvement of mast cells, which we will really start with tomorrow. Mast cells releasing histamine, and what histamine does is it balloons up your blood vessels, and the histamine does that in order to deliver more of these other types of cells, these second line of defensors, if you will, to the area. So when you have a big pipeline, so when your blood vessels are large, then you can deliver more stuff to the area, more agents. So to make your pipeline bigger, you would dilate it, and histamine would make that possible. So that would allow an attraction, or it would allow for more macrophages to show up in the area. The book uses the term attraction, but I don't know if I like that because this isn't like electromagnetism. It's just the simple fact that if your pipeline's larger, you can deliver more stuff to the area.